This is the summary for lesson 11. So let's look at two different figures. They both have the same, a line with the same slope, but that line is just in a different position. So in this figure, this line runs through, passes through 0, 0, and in the next figure, a line with the same slope is just shifted up 1 unit along the y-axis and passes through point 0, 1. So what does that shift do as far as writing the equation for these two lines? So looking at that relationship. So in the first case, you can figure out the slope of this line using this triangle, a triangle ABC. The vertical length is 2 units, the horizontal length is 1 unit. So the ratio of the vertical length to the horizontal length is 2 to 1. The vertical length is twice as long as the horizontal length. It is 2 to 1. In the second triangle, this is a similar triangle, and because it goes through 0, the length along the x-axis is the x value. So the x value is 4, the y value, actually the x value is close to 4, it's not exactly 4, but the y value is about 7.5, but not, it's estimating 7.5. So you can write that relationship as the length of y, which is y, and the length of the vertical length, which is y, and the horizontal length, which is the value for x, because it goes through 0. So that ratio is equal to the same slope, which is 2, which is a slope of 2. So it's 2 units along the vertical length is twice as long as 1 unit along the horizontal length. So the line goes through 0, 0. So x equals h equals the horizontal length. So this value of x is the horizontal length, and y is the vertical length. So y is equal to 2, x is equal to 1. So that ratio is 2 to 1. So the y value, the length of the vertical length, sorry, is twice as long as the horizontal length. It's 2 to 1. So the slope is 2 to 1, or 2. So using that, so 2 times the x value is equal to y, so 2 times the horizontal length. So using that, I can write the equation. So this is a similar triangle. It has the same slope. We've gone over why these triangles are similar. You can just translate this triangle. Actually, it sits right on top of this angle, and they both have 90-degree angles. So those triangles are similar. They have the same slope. So the slope of this larger triangle, triangle ADE, is y over x. So y to x, what does that equal? Y to x equals 2. For every value of x, y is twice as big. So if you go out here to 2 units, y is going to be 2 times 2, or 4 units. Go out here to 3 units, y is going to be 2 times 3, or 6 units. So locate this point, which is not on one of the lines. It's a little bit harder. So whatever value it is for x, y is going to be 2 times that value. This is the equation. This is the relationship for every point on this line. For whatever value you have for x, the value for y is going to be twice that value, or 2 times x. Now what happens if you shift the line up 1 unit along the y-axis? So in order to figure these relationships out, you have to subtract this 1 unit from the length, from the coordinate for y, to get the vertical length. The horizontal length is still going to be the x value, the value for x, because this goes through x equals 0. So you go back to this triangle, and this gets shifted up. So notice that this is still 1, but this length is going to be 3 minus 1. So this value right here is 3 minus this 1. You're going to get the 2 that way. So the y value minus this 1. I have to subtract that 1 unit along the y-axis. So this value, if you go out to this point, so it's at 1, 3, this vertical length is not 3. It's 3 minus this 1 unit. So the vertical length is actually 2. So you have to be able to calculate that to see if it matches the same slope. So this slope is, this vertical length is twice as long as this horizontal length. So the y value minus 1 is 3 minus 1. That equals 2. So the line is shifted up 1 unit, similar triangles. So you can use those, the slope of the triangle that you know, where you know the slope, to write the equation. You have to subtract the 1 unit in vertical length. So you go up here, this slope you might be tempted to write as the value of y over the value of x, but it's not. The vertical length along the vertical side is the coordinate for y minus 1, not y, but y minus 1. And that is related to x. So that relationship, the vertical length to the horizontal length, is the slope. In this case, it's y minus 1. The horizontal length is x. So y minus 1 to x equals 2. So let's plug in a few numbers here and see what happens. So if x is 1, y is 3, so this point, 3, 1, if I subtract 1 unit from 3, that's 2, and 2 times 1 is 2. So what about the point 2,5, which is on this line? So you go out 2 units and up 5 units. Does that fit the equation? Well, 5 minus 1 is 4, and 2 times 2 is 4. So the length of the vertical length is twice the horizontal length. It's 2 times longer than the horizontal length. So the horizontal length is 3 units. The vertical length is 7 minus 1, or 6 units. 2 times 3 is 6. The horizontal length is 4 units. Go up to 9. That's on this line. It's way up here. It's right here. So 9 minus 1 is 8. 2 times 4 is 8. So the vertical length is twice as long as the horizontal length. But remember, you have to subtract this 1 from the coordinate for y. So the last one, 5, 11. The y value is, the y coordinate is 11. You have to subtract to get the length. You have to subtract that 1 unit. So the length is 10 units. That's twice as long as the horizontal length, which is 5 units. So using the information of the slope, you're going to be able to figure out the slope from one of the triangles or one of the points, and relate that to the other point, which is going to be given to you in terms of x and y. And so you just have to remember when you have to subtract values, or if it goes through 0, 0, you don't have anything to subtract. So one last point. This point here is 0, 1. This is x, y. So x minus 0 is x, and y minus 1 is going to be the vertical length. All right, the summary for lesson 11.